In the last unit, we introduced the cost function, which is a function that tells you the minimum, cheapest way to produce a given quantity of a good. We also introduced marginal cost, which is the derivative of the cost function. And supply curves come from the fact that firms want to maximize profit, and it turns out the best way to do that is to set price equal to marginal cost. Once you have that equation, you solve it for Q, and you get the individual supply of a firm. And then once you have that, you take you just add up all the quantities across all the firms, and that gives you the market supply. But marginal cost is the derivative of the cost function, and that means that it doesn't contain sort of all the information that's in the cost function, right? Marginal cost is the derivative. What if your cost function is something like this? $10,000 to set up plus marginal cost is Q squared, or plus Q squared. All right, your marginal cost is 2Q, but your profit is going to need to clear at least 10,000, or else it's not going to make sense. So let's do a simple example. Suppose the price is 1, okay, and we have this profit function. There's our cost function. We take the derivative and we end up with this usual equation that price is equal to marginal cost. Set that equal to 0. We get Q is equal to P over 2. If P is equal to 1, we get Q is equal to 1/2. Okay? If that's the case, this guy's profit is 1/2 times 1, which is the price, minus 10,000 minus Q squared, which is 1/4. Okay? And this is really large and negative. Okay? Because the marginal cost didn't take into consideration the fact that you got to sell a lot of these goods if you're going to make back $10,000 in cost. So why didn't they sell more? Well, because it is true that selling Q equal to 1/2 maximizes profit. That's the best you can do. But in this situation, the best you can do is lose a lot of money. And if you try to sell more, you lose more money. If you try to sell less, you lose more money. And so by setting Q equal to 1/2, you lose the least amount of money, and that's what maximizing profit means in this case. Okay? But would a firm operate if it was facing these types of costs and this type of price? And the answer is no. Okay? And this is where free entry and free exit comes in. If profit is negative, firms are going to leave. And to sort of talk about whether profit is positive or negative, we need to introduce average cost. So average cost is the cost function divided by the number of units you sell. Okay? And in this case, where are we here? The average cost is 10,000 divided by Q plus Q. Because if you divide Q squared by Q, you get Q. Okay? What does that look like? Here's Q. Here's some dollars. Marginal cost is just 2Q, so it looks like this. It starts at 0 and it goes up with a slope of 2. Average cost is 10,000 over Q plus Q. So what does that look like? Well, if Q is close to 0, let's just write this again. If Q is close to 0, average cost here is close to infinity, because we have a 0 plus 10,000 divided by 0 is going to be infinity. Okay? On the other hand, as Q goes to infinity, average cost goes to infinity again, because as this thing is really large, the first part falls to almost nothing, and your 10,000 divided by infinity is 0. But then if we add infinity to it, we have infinite costs. But in the middle, it's something positive and, not necessarily that large. For example, if Q is 5,000, then 10,000 divided by 5,000 is 2 plus 5,000, so it'd be 5,002. which is big, but a lot smaller than infinite. Okay, so this is going to look something like this. It's got a dip because it starts at infinity, it ends at infinity, and it comes down to sort of a positive realm. And it turns out that an average cost function that looks something like this is really common in these perfect competition models. It looks like the letter U. Okay, it starts small, ends big. And that happens anytime there's like a fixed cost to production, but you have increasing marginal cost. Okay, so why is average cost important? Because in the long run, if price is less than average cost, firms exit, which means Q goes to 0. Okay? If price is less than average cost, so if price is down here, then we set the price equal to marginal cost. That tells us the profit maximizing quantity. But since price is less than average cost at that point, firms lose money each time. And we can actually draw a little diagram to show us how much money they lose. They sell this many units, and this area here is the loss per unit sold, because we're taking the average cost to make that unit, we subtract the price, and that's our loss, and we multiply that by the number of Q, and that's how much that's our total loss. Okay? For a firm to stay in the market, it needs to find a price that is above average cost, or at least equal to it. Okay, so in this case, if the price had risen from, say, this P1 to P2, the firm would maximize profit by setting price equal to marginal cost again. And now price is higher than average cost, and so it would be making this area as positive profit. Okay, there would actually be a little dash here. And again, the price minus the average cost at that point would tell us the profit per unit, and then we multiply that by the number of units. Okay, so it's very important to recognize that, let me just summarize it here. Price equals marginal cost determines the short run supply, because it's how you maximize profit. But in the long run, if the best profit you can make is negative, then you're going to exit the business. It's average cost that determines long run supply. And this is in sort of more ways than we've even covered so far. But for now, we'll say if price is less than average cost, firms exit. Whoops, let's say Q goes to 0. Okay, they stop supplying the market. They just close up and cut their losses. Okay. Given that, let's start to build our supply and demand framework.